In this video, I'll do some example problems with trig and inverse trig functions. And the first type will be when it's a trig of an inverse trig. This is my own way of writing it. This is not a standard thing you find in textbooks. But this is where the inverse trig function is in the inside and you're doing the trig function of an inverse trig function. Okay? Here's the first example. Cosine of the inverse sine of 0.5. Now you don't do math left to right. You do it inside out. Okay? So you do it from the inside out. So first we need to figure out the inverse sine of 0.5. Inverse sine of 0.5. Okay? And you could, if you had a calculator, you could just do this on a calculator, or you might know it if you ask, like, which angle, remember inverse trig functions are angle, like the previous video. So it's saying which angle has a sine equal to 0.5. Well, here's 0.5 on the y-axis. I could go this way or this way, but the sine, inverse sine answers are restricted to -90 to 90 artificially by us, by people. So we have to go to the right and we get 30 degrees. So inverse trig functions are angles. This whole thing is the angle 30 degrees. So this is the same thing as asking, what's the cosine of 30 degrees? And for that, you would get square root of 3 over 2. That's one of those cardinal points, 0, 30, 45, 60, and 90, and then so forth around the circle. You're supposed to have those memorized. It's a really good idea, if you're into math and you're willing to put in the extra time, to also know them as decimals. They make a lot more sense if you can quickly convert them to decimals. If you know that, just memorize it. Memorize what the decimal equivalent is. Of course, you know the decimal equivalent of 0.5, of 1/2, right? 1/2, these are the three you have to learn. 1/2 square root of 3 over 2, and actually we'll put them in order. Square root of 2 over 2, and square root of 3 over 2. Square root of 2 over 2 is 0.71, square root of 3 over 2 is 0.866, or just 0.87. If you memorize those two, life gets a lot easier. Okay, so that's the first example. Second example would be sine of, just for more practice, inverse cosine of 0.5. Okay, let's see. Inverse cosine of 0.5. That's an angle with a cosine equal to 0.5. So which angle is a cosine equal to 0.5? 60 degrees. So that means we're doing the sine of 60 degrees, okay, which also happens to be square root of 3 over 2. Okay. Third example is the tangent of inverse sine of square root of 3 over 2. Okay, so think about that for a minute. You can pause the video and try it yourself. Inverse sine of square root of 3 over 2. Now, there are other ways to do this. We're just doing it the most straightforward way. If you have to do it a different way, if you have questions on it, you can always email me. But we're doing it the most straightforward way for like beginner understanding. Okay. This is asking what angle, remember inverse trig functions are angles. What angle has a sine of square root of 3 over 2? Well, this is one of your cardinal ones. This is 60 degrees. So this is actually asking what's the tangent of 60 degrees? Okay? And there are different ways to figure that out. You might have it memorized, or you might do it, I think most students do it this way. Well, it's the sine of 60 over the cosine of 60. And that means it's square root of 3 over 2 divided by 1 over 2, and so it's the square root of 3. So that's the answer. The tangent of the inverse sine of square root of 3 over 2 is the square root of 3. All right, second type is if the inverse trig function is on the outside and the trig function is on the inside. There's one more type where you have like, well, we'll just stop with that. Okay, so this inverse trig function on the outside, trig is on the inside. Again, this is my own notation, trig with a -1. That's not standard, but I think it tells the story. Okay, so here's our first example. Inverse cosine of the sine of 30 degrees. Okay, you do math from the inside out, not left to right, so you do this first. The sine of 30 is 1/2, or 0.5. So all of the inside is 1/2, so that means we're trying to figure out the inverse cosine of 1/2. Okay? You could just put that in a calculator, or you might know what it is. Okay, so 1/2 would be here on the x-axis because we're talking about cosine. We go up or down, but remember we learned that inverse cosine has its range restricted to 0 to 180 degrees. It wears a hat. So we go up to here, and we get 60 degrees. So the answer to this first one is 60 degrees. Okay, second one, let's do the inverse cosine of the sine of 150 degrees. Okay, the sine of 150 degrees, that's up here. And whatever way you have to figure that out, you figure it out. But that's sine of 150 degrees is 0.866, or square root of 3 over 2. Whether you get to use a calculator or not, or whether that's one of the ones you have memorized, you can see it's y-coordinate, so it's positive. It's when the y-coordinate is longer than the x-coordinate's length, and so it's the square root of 3 over 2 instead of the 1/2. So sine of 150 degrees is square root of 3 over 2. So now we want the inverse cosine of square root of 3 over 2. So you imagine marking square root of 3 over 2. Okay, that would be here. And the inverse cosine of that, remember we go up like this. Okay, that would be 30 degrees. Okay. Oh, I'm sorry. Yeah, I did that right. 30 degrees. Okay. Finally, an interesting twist here. The inverse sine of the sine of 30 degrees. Okay, you think, okay, well, inverse sine cancels sine, so it's just 30 degrees. And that would be correct. But what about the inverse sine of the sine of 150 degrees? Okay. You might think, oh, an inverse cancels the sine, so it's 150 degrees. I'm going to put a big warning in here. It's not 150 degrees. And this is why. And try it in your calculator. Set your calculator to degrees, type this in, and you'll see it's not 150 degrees. But before you try it, see if you can figure out without a calculator why that's true. Okay, here's why. Draw a unit circle. Okay. And if you have a copy of the paper calculator, all this can be done in the paper calculator much more accurately. Okay, and we do 150 degrees. That would be over here. We don't even have to draw the hypotenuse or that radius. We can just put the dot at 150 degrees. And then think x-coordinate and y-coordinate. Okay, the sine of 150 degrees is the y-coordinate of the dot. So that'd be here, because sine is the y-coordinate. That's 0.5. So that means we're actually doing the inverse sine of 0.5. Now at this point, this is all the inverse sine knows. It's doing the inverse sine of 0.5. It doesn't know where that came from. It doesn't know it came from originally 150 degrees. All it says is, I am the angle whose sine is 0.5. Well, there's infinitely many angles. There's 30, there's 150, there's 390, there's negative 330. It's just infinitely many. And remember, we artificially restrict the range. So now you forget where this came from, and you just look at that. The sine, inverse sine of 0.5 is 30 degrees. Because of this range restriction, remember the inverse sine family wears a fencing mask. Okay, the restriction on the inverse sine is from negative 90 degrees to 90 degrees. So your answer has to fall in there, and that would be here. That's 30 degrees. So the inverse sine of the sine of 150 degrees is not 150 degrees, it's 30 degrees.